Welcome to another AP podcast, section 4.5. This is on types of reactions. And the first reaction we're going to look at is something that you have seen before, and that is precipitate reactions. So you're very familiar with them. We spent some time with them, and this will hopefully go quickly because most of this is going to be review for you. So basically, just a quick review of a precipitate reaction is let's say I have something like silver nitrate, and I add it to some sodium chloride. Now I add those together and some magic happens, and if I'm looking in my beaker here, I've got the liquid there, but at the bottom I've got some kind of precipitate. Oops. Alright, I got some precipitate down there. And so what happens is when you mix two liquids together and you get a solid, okay, that solid, we call that a precipitate. And as a wise old chemist once said to me, if you're not part of the solution, you're part of the precipitate. So there you go. All right. So let's look at an example. Here's an example of a precipitate reaction. We've got sodium hydroxide. We're adding some iron chloride. Now they mix, and you'll notice from last year, this is just an example of a double replacement reaction. The cation from that one combines with the anion there, and that there. They just kind of switch partners, so to speak. So they make sodium chloride and iron hydroxide. Now, if you think about all the ions floating around in one beaker, all those positives and negatives floating around, they come together, and this is the only thing that really happens. You make some solid iron hydroxide, and of course that's very important to notice that. You make some solid hydroxide. Pardon me, iron 3 hydroxide. So what's happening with the chloride and the sodium? Well, they're still floating around. They were floating around before, and they were floating around after. Excuse me. And so the precipitate reactions we're going to focus on are all going to be double replacement reactions, and we'll just do a few things with those. So let's look at a couple. Let's look at a couple more. First of all, these only occur if you get an insoluble product. In other words, if I take two solutions, mix them together, and nothing happens, well, then there's no reaction. Okay. Now, if we get some bubbles or heat, something else is happening, but it won't be a precipitate reaction. So then that brings us to this. Okay. Those of you that spent some time with me last year already have flashcards for the solubility rules. I asked you to memorize them over the summer, and if you haven't, now is the time. You need to make sure that you memorize those rules, and it's on page 152 of your textbook if you really need it. So let's look at a couple reactions. So here's a bunch of double replacement reactions, and I'm just going to write out a couple. All right, so I'm putting silver nitrate and potassium chloride together. So what would happen? Well, silver and chlorine would come together, and KNO3. Now, my question to you is, which is the precipitate? Well, hopefully you would go, well, duh, it's this one, because you know that chlorides make precipitates with silver, lead, and mercury. APH is on the sheet, okay? And nitrates and group 1 metals never make precipitates. So let's look at these two. What would these two make? Well, you would make zinc dichromate and barium nitrate. So we're not going to spend the time doing the rest of those. If you want, you're definitely welcome to try, and then you can ask me tomorrow if you got those right. But again, a lot of this is review. So let's move on to the next thing. Now, when we talk about our three types of equations and we talk about precipitation reactions, there's three different ways to write them. One is with a molecular equation, and all that is showing everything. So showing all the compounds, molecules, whatever you happen to have. And that's when you would get something like this, where you have the products over here would be potassium nitrate and barium chromate. Boy, this pen, guys, I am so sorry about this writing. This is horrible. And then a complete ionic equation, and again, we did these last year, is where you simply just take all of the molecules involved, or all the ions involved, and you just break them up. We have 2 potassiums there, you have 1 chromate, you have 1 barium, you have 2 nitrates, you can see those right there. Okay, then we make the solid, barium chromate, and then we still have 2 potassiums and 2 NO3s. Now, what are the ions that are not involved? Well, those are called spectator ions. All right. And if you'll notice before and after the reaction, the potassium and the nitrate is exactly the same on either side of the arrow. Okay? So when they're the same on either side of the arrow, and that's the same state of matter, and I didn't write, we're just assuming all these are aqueous, well then those are the spectator ions. Okay? And last but not least, when you write the reaction of the ions involved, that's called the net ionic equation. And that just shows the ions that make the precipitate. So in this case, it's barium plus chromate gives you barium chromate. All right. And so one of the skills we want to make sure we have is we want to be able to write all 3 of those types out. Although this one right here, this by far is the most important, because when you do reactions on the AP test, they only want you to write the net ionic equation. So let's go ahead and try one of these and see what happens. Write the 3 types of equations for a reaction when the solutions are mixed. So I'm just going to go ahead and write this out. Chromium 3 chloride, so CrCl3 plus sodium hydroxide, NaOH. Okay. Now this is a double replacement reaction with ions, so I'm going to take the cation from the first reaction, chromium, and I'm going to combine it with the OH. Okay. And again, we're making sure the charge is balanced, plus sodium chloride. Now I need to do a little bit of balancing here, so I'm going to have to put a 3 there and a 3 right there. Okay, so now this is a balanced equation. Okay, the next thing I need to do, and that's a molecular equation, I need to write a net ionic equation. Well, chromium 3 plus 3 chlorides I should say, plus 3 Na pluses plus 3 OH yields. Now, which of these 2 is my precipitate? Well, sodium chloride you know is soluble, so this must be my insoluble compound. So chromium hydroxide plus, I'm going to have to put it down here, 3 Na pluses plus 3 Cl minuses. Now you look at that, what are the spectator ions in this reaction? Okay, well, hopefully you see that the 3 chlorides are the same there, and the 3 NAs are the same there. So those are my spectators. And so the last one is, what's the net ionic equation? Remember, the net ionic equation is the reaction that only occurs with the ions that make the precipitate. So here's the net ionic equation. Chromium 3 plus, boy, I really don't like that little automatic erase, plus 3 hydroxides yields chromium 3 hydroxide. Right? Oops. All right, so there's your net ionic equation. So this one right here is the molecular. This is the complete ionic equation, and last but not least, this one is the net ionic equation. All right? So now with all these skills we have and those solubility rules that hopefully we've memorized a little bit, let's look at a little example out of your book, because I really like this problem. Pause the video for a second, read the question, and see if you can figure which ion or ions are present in the sample solution. All right, so did you come up with your answer? Well, let's look at this. Let's look at the first one. The first one says that no precipitate was formed when aqueous solution of NaCl was added. Okay. Well, sodium, you know, is not going to ever react with anything, but we know, hopefully, the rules for chlorides, right? The mnemonic I have is A, P, and H, right? And that stands for silver, lead, and mercury, right? So if no precipitate was formed when you added that, then that takes away this mercury right here. All right, let's look at the next one. No precipitate was formed when an aqueous solution of sodium sulfate was added to the sample solution. Well, sodium again is not going to do anything, but how about the sulfate? Okay, what's the sulfates rule? Well, that was CBS, PBS. And that stands for, I'll write it down here, calcium, barium, strontium, and lead. Okay? Those are all 2 plus, by the way. So that takes away this one. Okay? Well, let's look at the last one. A precipitate formed when a sample solution was made basic with NaOH. Okay, so now we have OH floating around, and there's really only one. Since we have a precipitate, most hydroxides are insoluble, so there must be some Mn2 plus floating around. Hopefully that's what you got. All right, so if any of this doesn't make sense, please ask me about it in class, and hope this all made sense to you. Have a great day. Bye.